This tutorial will deal with the assembly of furniture using joints. The previous tutorials in parts and assemblies just used flush face joints and mating. The previous tutorials for this involving coil, emboss, rib and chamfer, they're all dealt with separately. So I'm just going to go ahead and just create a simple door on this occasion, create joints on the end of the timber sections and assemble the whole door together using parametrics to Excel. So the first thing I'm going to do here is just create a standard part as usual. And I'm going to start Excel now as well. This is basically the same method I used before. However, this time I'm just going to be incorporating the joints into it. It's very important that all joints are correctly parametrically driven, and that if any adjustments are made in the Excel sheet, they reflect properly on the inventory drawing. So I've just set up my first few parameters here now, and just widen the cell there so you can see everything. And this involves the rail length, so all the rails, the top and the bottom, are the same length. The top rail height and the rail thickness. So I just saved that there now. I'm just going to link to the Excel sheet. I can insert these dimensions here now, which go back to the list parameters menu and relate to the Excel sheet. I can extrude this now as well as the top rail height. And I can save this part of the drawing. I'm now going to insert the different dimensions for the groove in the timber itself to take a glass panel in the centre of the door. Now that Excel file has been saved, I can create a new sketch now to create the actual groove on the bottom of the top rail. I'm just going to draw a small rectangle first, just because I don't want it to constrain itself to another point by accident. And now I can actually just apply my parametrics now. Finally, there's a third dimension. And now I have a rectangle that I can basically create a cut through the entire length of the section. So just select and through all and OK. I'm now going to create a shoulder on the top of the joint. This is basically so the joint will not extend to the very top of the stile. So for this I'm just going to use the same as the groove depth, which is 20mm. And now I want to actually put in the length of the tenon, which will be the same as the stile width. So now I go back now to manage and update my parameters. Now I can put a dimension on the width of the rectangle, which is going to be the length of the tenon. In this case it's 110mm. I do the exact same now on the other side of the head rail. I could copy this section across, but I'm just going to create a new rectangle just for the purposes of clarity of this tutorial. The exact same here now again. It's 110mm by 20mm. I can now finish the sketch and extrude a cut through these two parts. Once again, just cut and through all. The next thing I want to do now is actually cut out the tenon. So I'm going to take a small bit off the left hand side and the right hand side. So I'm going to draw another simple rectangle. Make sure it doesn't constrain itself to anything else. And now dimension this accordingly. We now finish the sketch and I can cut these two rectangles through all, click OK. I'll do the exact same thing on the other side. Since the rectangle is the same length as the face below it, it'll automatically be constrained in length, so it's just the width that needs to be dimensioned. So that's the same as the other side. And now you can do the exact same thing again, just finish the sketch, extrude and cut the two rectangles through all. So at the moment now I have my top rail, it has the groove in the bottom, it has the two tenons, one on each side, and the center peg section. I can now save this part. Now I can create a new part. And this is going to be the style. So I'm going to have to add a few more parametrics. Once again here I'm just going to incorporate some formulas into the Excel sheet. Back now I'm just going to create another standard new part, link in the parameters, link it to my previous Excel sheet, and when this imports just click done. So now once again I can draw my rectangle in the sketch mode, dimension the thickness, now dimension the width. Finally, once again, I can finish the sketch and extrude to the length required, which is the same height as the door. Now that the style has been saved once again, I need to be able to create the mortises to accept the tenon from the head and the sill. Now since the tenon on the top rail did not start at the very top of the rail, I'm just going to first create a rectangle to represent the section that is not to be mortised out from the style. So if you remember, this is the same as the groove depth. And now to this rectangle, I can constrain a new rectangle. Now first I was going to place in the bottom like this, but after some consultation I decided to place it from the very top. The main reason is because I'm missing a parameter for here. So just undone that, draw a rectangle from the very top, and now this is the height of my top rail. And now I must remove the groove from the bottom. So draw another rectangle, constrain to the previous one, and dimension that my groove depth. This is now the style with the mortise created on the top. So the next thing I'll do now here is create the mortise on the bottom. These are going to require a different set of parametrics since the bottom rail is higher than the top rail. When that Excel sheet is being saved again, I just update the parametrics. And now I'm ready to draw another few rectangles here just to create a cut using the extrude command on the bottom of the style. So once again, I do the exact same procedure as I did on the top of the style. Once again, this top rectangle is the actual area that's going to be mortised from the style.